Hello, thanks for coming to look at my Joseph Moxon lathe video. Latest update on there, I've got a drill bench working. The picture that you can see in front of you here is the actual drill bench in the diagram from Joseph Moxon. You know my lathe, you've seen it before, you've seen the great wheel working, you've seen all those things. That's a little side rest, we won't go into detail on that. This here is the drill bench. 18 inches long, this drill bench. He describes it as having a metal strap underneath. I'll show you that later. I've followed his description. He's got a stile at the front and a stile at the back. A stile, call it a leg. Notice the length of this pulley here. I thought, why on earth has he got such a long, flat pulley? He talks also about a piercer bit. Anyway, we'll go into detail. I just wanted you to see the Joseph Moxon picture. All these letters here, all in detail, explaining what every part of this is. Pulley, stile, piercer bit, etc. So, anyway, onto the drill bench itself. Okay, here's my pricked piece of stock here. I've just put a point in there just to give it the a guide for the drilling process. I've got a piercer bit here that I've made. This is the same as the 17th century ones, as much as I can gather anyway. Trouble is, the flat drill bit that I've converted here as a hex shank, which has created some problems for me. So, for the purpose of just the drilling demonstration here, I'm using a modern drill bit. It's a modern lip and spur, because basically it just fits into there for now, but that will change as time goes by. Well, let me demonstrate exactly how this works. Using the treadle, which I will show you later, you press down on there like you would any kind of drill bit when you're trying to make a hole, and you'll see I'm turning the whole thing 1/3 turn, just like Joseph Moxon describes. Well, actually he says to turn it deftly. I'm not sure how deftly I'm actually turning this. He reckons that what it does is it keeps the whole thing centred, and I think he's probably right, but I've noticed the other thing that it does is enable the string to go back up, to return. Yeah? So it also has that, I would say, added advantage to it. Now you might say, why would a wood turner use a modern drill bit, not a modern drill bit like this, but you know, why would he use a drill bench when he could use a brace and bit? Well, in the 17th century they called that a whipple instead of a brace. I can show you one of those. I've got one over here. I'm not sure if it's exactly an original one. But looking over here, you can see the typical wooden brace that they describe in the 17th century. Everything's made in a similar way that it would have been in the 17th century. They were still being used in ships in around about the early 1900s as well. This is made by a blacksmith. You can see how it's been bashed out as well. So you can see how the original the original piercer bits were actually made. So you might say, well, why wouldn't a wood turner use one of these? Well, he might have done, but it's unlikely because the strength is in his legs for a start. And you think about how hard it is to hold a round piece. It actually takes quite a lot of effort. You know, if you're going to put it into a pillar drill, as we would call it, or a press drill, what you're going to find is that you need a special vise to hold it in, so it's central. Now, I'm not putting a great deal of effort into this. I'm really not shoving hard. If I was to press much harder, like you can see a lot more dust actually coming out of there. It just requires that extra effort. And of course, I'm only doing this here for a demonstration for you. So the harder you push on there, and the harder you push down with your foot, yeah, the more you're actually going to get out of the end of there. Yeah. Okay, so it's just a little bit of effort like that, not too much. I can show you the hole that we've made already. If I just put my finger on the point that we've got up to, which is about there, you can see that in those, what would that be, about 20 seconds? I've done, say, ½ an inch. So certainly in 1 minute you can do an inch. So okay, it's going to take you 6 minutes to do an inch, maybe less than that, I'm not too sure, and I think the piercer bit will be better at it. But anyway, it gives you an idea how the whole thing works, and you can see as well, I'll demonstrate this without actually drilling something, just so you can see it. Just watch the string ride along this pulley here. I used to have a pulley that was much smaller than this before I made this one. That's much more like the one in the diagram, this one. The string used to ride completely over the sides because the pulley was too small. But that explains why he's got such a long, flat pulley on here. Anyway, let's go and have a look at the treadle now. Okay, well, here we have the treadle, and this is the string. Joseph Moxon describes how to place this string, so you do it in a figure of 8 fashion, like this. That means, of course, that what you can do is have less or more of a range of, a rotation on your drill bit. Now, obviously if you take it out almost completely, you're much more restricted because you've only got that distance down there to the floor. The further up you go, way up there, the more your drill bit is going to turn, but the more pressure that you've got on it. So, I unravel this from here. This is the same design and to the same specification Joseph Moxon gives. I've used a modern piece of string that pole turners will use because I thought that would be more durable, but this is only as an example piece. It's not what I'll have for demonstrations for the public. So if I just remove that from there, you can see that just hooks on there with a knot, that's all it is. Down at the bottom here you can see the treadle. The treadle here makes a kind of A-frame here and gives it that extra stability so that this isn't just wobbling about too much. I've got it against this stile here which gives it even more support. Okay, here we are back up at the top of the drill bench. This is the string at the other end that you saw going up and down like this. Now if I pull that through, that's where my bit was that went to the treadle, take all that through there. I apologise for anybody that's using a pole lathe, but you know, because they'll understand about all this kind of thing. But in the 17th century there are all sorts of complicated ways of getting this string to go up and down. My preferred method is going to be weights, so I'm going to have a weight drop down the other side so that it gives it that extra, you know, so it looks a little better. We talk about bows, and poles and all kinds of different methods and even springs and things for making things come back. But for now, I just thought I'd just demonstrate how the string wraps around and how it moves. Inside here, you can see the slightly square shank on there. That's what keeps the roller, obviously, from twisting along the shank itself there. So there is a square roller. There's another little square on the other end there, sorry, square that goes inside the roller at the other end. So it sits across both of those, right? Okay, now what I also wanted to show you was the underside of the lathe, where it goes under the lathe, where the drill bench fits. And if I can just tap this out here, I'll show you. I have shown this on a previous video, but not since the whole thing has been up and working. So if I just tap that out there, usual thing, sorry about my arm being in the way there, usual thing is it's a wedge that's in there from a bit of spare oak that I've got, and underneath you can see how the whole thing lifts off. Now under here I feel fairly secure about moving all that round because it's all fitted in position. I'm going to demonstrate how those pieces are placed in there anyway. Under here you can see a square bar that I've filed down in the corners and then turned square. I give a demonstration of how that happens on a previous video. I've cut a slight slot for this to fit in so that it reaches properly. Drilled the holes through here. I couldn't get the holes big enough, so I've had to file them out, drill them as size I could, then file them out, but they didn't need to be perfectly round. Fitted the coach screws into there, so the whole thing is screwed in place. This is, again, exactly as Joseph Moxon describes it in his treatise. He describes it as ironwork underneath, whatever, in a square of this size, you know, and then in place with the wedge. So I'll just fit that wedge back into there so you can see how it goes. The specifications are correct. He says 18 inches. I'm just going to tap that in there with my hand this time rather than actually tap it with a mallet, so I'm not in your way. What I'd like to do next is demonstrate how the whole thing is constructed and how this whole thing works. Right, well the string's back on in place now. What I failed to mention was I noticed on Joseph Moxon's picture that these sides here were slightly sloping. I couldn't quite understand why that would be, and it's complicated to do that instead of using a block of wood. You can see the line on here. You know I've used more than one piece of wood anyway because all this is beech and I could only get beech to that size at the time, so I've glued two pieces together here to make the one block the size he wants. 3 inches by, I think it was 5 inches, you can read his treatise, and the whole length 18 inches for this, and then the sloping sides down here of course, and that's where the string will ride. Otherwise this is going to come out and it's going to rub and cut into the string all the time, isn't it? He gives no explanation for that. It's simply in his diagram, and I thought, why go to the trouble of that? But I've done it anyway. Now the interesting thing is, you see the length of this, it's 18 inches the bench. That means that this axle here, with the stiles the way I've built them, actually fit incidentally or accidentally with the mandrel that you can see over here. If you look over here, underneath this mandrel is the wheel. Now this wheel, this treadle wheel, has a crook on it. He's given no specific length for the crook or anything, but in order to make the wheel to the thickness he describes and the size he's described and get a crook that will work, I've had to have the mandrel along here a certain length on what we call the puppets along here. Incidentally, the axle that you see on the drill bench is almost exactly the same size as the length of this one here. And with the adjuster at the end there, the screw, I can actually use the drill bench mandrel on this, which makes me think that's why he suggested an 18-inch length, which I thought was extremely long. I think it's so he can perhaps use it on here as well. I don't know that, but it's a strong possibility. Now, what I'd like to show you is how this whole thing is constructed. Clever design here. Now, if I just loosen this here, this is a kind of collet. Now, what I've done, I use the leather, by the way, because I don't want to damage this. It's rather nice, isn't it? And if I just unscrew this, I have to have my hand under here while I do this. You can see the drill has already come loose. I can take that out. That's because there's no tension there anymore in that collet. I take this out here, and this is where the clever design comes in. It's not something I've thought of myself. Do you see that drop out there? That little piece just dropped out there. Now if I've put my string back on purpose so that I can turn this round so you can see where that goes. Can you see that little slot in there? What happens is the little slot there is tapered at the back. So when the collet screws on in place here, what it does is it pushes down on this little piece here, and that tightens my drill bit. Now there's no explanation in Joseph Moxon about that at all. That's something that my clever engineer designer has come up with all by himself, and I think it's an absolutely brilliant idea. But what Joseph Moxon talks about is the drill bits either being permanently fitted to each mandrel, or he talks about different size ones being slotted in or fitted in. He doesn't actually explain how that happens, so we've had to come up with this design ourselves. Well, I say ourselves, he's had to do it by himself. So it's a brilliant little design there that I thought I'd show you that makes sense. And I have an old brace and bit that they call a whipple from the period, as I explained before, a wooden one, yeah. And that has something very similar inside it. It's like a little screw that goes in, or a little peg or something that jumps out slightly when you shove your drill bit in. You know. Anyway, I'll just tighten that up a little bit more because it's going to come loose. That, so I'll just tighten it up with that, just so I've got that extra tightness on there. It's not tightening too much, otherwise it will slip on the leather. But the main thing is, it holds that drill bit in place there. You notice it was a round shank on there. Well, what I've done is I've just filed just a little bit square so that it seats nicely into that part there. So, let me show you now how the whole thing is constructed. And again, from the pictures, this engineer friend of mine, I've mentioned his name before, Peter Trett, who I'm very grateful for, has designed all of this for me. Square nut on there. Much easier to make square nuts than it was to make hexagonal nuts. Square piece of bar, cut off into slices, using a common term, and then threaded, but drilled and then threaded. Makes sense, doesn't it, rather than going to all the efforts of a hex. So, I'll leave that in my box over here. You can now see that what can happen is this whole thing can move along here. This here is a separate plate. I'm not going to take that plate off, but I could do if the collet wasn't there. Bring this to the end here, and you'll get the idea how the rest of it works. On here, there's a collar. See that collar there? That's what it goes against, yeah? So it can't slide forward and fall out of the back. Let me show you the back. The back, over here, is a pin that goes into a hollow on here. Now, I know what's going to happen here, because I've got the string attached, is it's going to... Right, there you go. You see how that comes out of there? Now, you can see that this here, right, pins into the back of there. So it spins nicely. Bit of grease in there, so it spins beautifully. What I've done is I've shaped the back so it sits nicely in place, just there, like so. Yeah? And the reason for that is that it stops it all spinning around. Now I could glue that and fix that into place if I wished, but there's no need really for me to do that. Anyway, I just wanted to show you how the whole thing was constructed. I'd like to explain as well one other thing, and that's a break away from what Joseph Moxon had said. What he suggested was a metal plate in there with a hole in it with a pin on the end of here, sorry, on the end of the axle there, that then fits into that hole. I've broken from that because, as I said to you before, this mandrel can then be used over the other side on the other part of the lathe. So I'm not sure why he was suggesting on this occasion, whereas all of the mandrels are hollowed at the end, that this one should have a pin in the end. I've broken away from him on that one, so I apologise to you there, Joseph Moxon. On every other point, I find that all your advice is excellent. Now there's one other thing I'd like to mention. Cut. Okay, my final point. Joseph Moxon, in one of his other diagrams, shows different, what he calls, collars. You can see one that's mid-bottom, called H, the circular one with the holes in. Next to it is I, a simpler one, and then G, a much more complicated one. Then he handily, I think maybe he's in the payoff, knew the person who made these and actually gave the address where you could go to get them made because they're quite complicated. Those on the right there, the ones called G, they're the ones, the clamping ones if you like. Therefore, if you're using wooden mandrels, so you can use different sizes. I didn't need that because I opted for the metal mandrels. Now, looking down you can see various rollers on the page there. I won't bore you with the details on all of those. I'll just show you a demonstration really of how mine is similar, or the same, I hope anyway, as H. You'll notice he shows it on a puppet. That's a puppet that can be on the lathe. When he's describing the drill bench, he says any one of the collars shown on plate whatever, yeah, I forget the number of it now, yeah, can be used on the drill bench. So I could have used any one of these. Or, he says, you can even use just a wooden board with a hole in it. I've gone for the circular one. This, as you've already seen, will detach from here. The round plate will detach from there just by that locking nut that I've got on there, and can be placed, as you can see in the diagram, on a collar, like this, as a collar on a puppet, so it can be used as a steady on the lathe. That's why there are different sized holes in this. So anybody who's watching this thinking, well hang on, he's only using one hole on this drill bench. Why on earth has he got a round plate with all these different holes in? And that's because Joseph Moxon says this is a steady, and the collar that you use as a steady can be used on the drill bench. So I wanted to explain why I've chosen this one. It will rotate, so you can use any one of the different holes. Perhaps that's for another video though, when turning small pieces of work, almost like dowel, say half-inch, quarter-inch stuff. Anyway, thanks for watching the video. I hope you've enjoyed it, and I hope I've brought the Joseph Moxon drill bench to life for people that wanted to know how a 17th century wood turner would actually bore holes in his pieces of wood to fit them to the worm screws on his lathe, so he can then get in at the end of them and turn them that way rather than between centres, or so he can bore deep holes in boxes before then turning them out. Perhaps, who knows, but that's how the drill bench works.